Hello friends, welcome back to the new video of Math. So today we are going to discuss the chapter triangles and some problems based on chapter triangles. So in the previous video we have done on periodic table of class 10 ICSE board. So after teaching this lesson I would also like to try on class 10 ICSE board maths. So without delay, let us go into the video and comment below whether you want it or not. So let us go on to the first question. The question is on your screen. That is, here a figure is given and here it is given AB is parallel to FT. So this is the parallel symbol. We'll represent it with. So AB is parallel to FD and AC is parallel to GE. And BD is equal to CE. So prove BG is equal to DF and CF is equal to EG. So let us first do the first bit, that is BG is equal to DF. So let us first write what is given information. So we are having here BD is equal to CE. I will write here BD is equal to CE. So I am representing it with one line here. BD is equal to CE. So now they are asking to prove that this line BG is equal to DF. So now let us take these two triangles. Now from here we are having angle ABD. Here you can see angle ABD is equal to angle FDE, because as this line is parallel and here a transversal is going on. So when these two lines are parallel, so this I have already said in the previous videos, so you can check it out. So when two lines are parallel, so I will draw it here on the horizontal type. So here we will get, if these two lines are parallel and one transversal is crossing through it, we will have this line is equal to this line, this angle. Sorry, it is, suppose if I name this point A and B, so angle A will be equal to angle B and the reason will be corresponding angles. So that is corresponding angles, and that happens only in a case of parallel lines. So here, as I have said, triangle GEB and triangle FDC. So first one we have to prove those congruent triangles. Those triangles are congruent. So now you are having angle ABD is equal to angle FDE, thereby corresponding angles. So angle ABC or angle ABD, you can also write it as angle GBD. So the angle should be in middle, that is the angle name, and is equal to angle FDC I have written, or FDE. Any angle is correct. So next we are having angle GEB. So angle GE and B. So this angle GEB is equal to angle ACB. Angle ACB. So this angle. and this is also same case, that is here we are having same corresponding angles. So I will write angle GEB is equal to angle ACB. So this is also same reason we will write for it. Now we have to prove another side or whatever it is, we should prove in order to fill the congruency. So now let us see what are we having. We have BD is equal to CE. So BD is equal to CE, but now carefully taking out these triangles GBE and triangle FDC. Now here it is given in the question BD is equal to CE. So BD from here to here is equal to CE. Now, so if I prove BD is equal to CE, it will not fill the congruency because there are two different triangles. So I should prove here this BE is equal to CD. So pause the video right here and think what could be the reason to solve it. I hope you have done it. So now let us see how. We are having BD is equal to CE. So I will write it on the next page. BD is equal to CE. So you know, I hope you know that whatever we do on LHS, we can do on RHS. That is, if 3x is equal to 6 is there. For example, let us take this equation. So if I multiply this with 3 and RHS also with 3, LHS and RHS also will be 3. So I will get the same value. This will be 9x, which is equal to 18, and x will be definitely 2, and here also x will be 3 1s are and 3 2s are, x will be definitely 2. So this one I want to prove BC is equal to DE. Sorry, BE is equal to DC. Now I will add BD plus DE. BD plus DE is equal to CE plus DE. I have done, or I added DE on both RHS and LHS, so the equation will be balanced. So as I have said, now we can do whatever we have done in LHS, we should do in RHS. So I have added DE on LHS, we will have DE on RHS too. Now here BD plus DE. BD plus DE. You are having BD plus DE. So now BD plus DE, you are having BE. So you are having BE. So I have written here. And we have on RHS CE is equal to DE. So what is CE actually? CE is here. So I am representing it CE plus DE. So you are having CE plus DE, which is equal to CD, which is equal to CD. So I am explaining it again. So what we are having on LHS is BD plus DE. I hope you got how I got this equation. I added DE on both sides. on applying law LHS is equal to RHS. So now I have BD plus DE on my LHS. So what is BD plus DE is equal to? So if a line is drawn here and I'm having this line, this point this point B and this point D and this point C. So I can write this line as BC because I am having the end here and end. So I will write it as line BC. So I can write BC is also equal to BD plus DC. So this whole line length is nothing but, I am representing it with blue color. So this BD's length plus DC's length, you are having this whole value. So this value BD's length plus DC's length will be equal to the whole length of line BC. So that is what the law, or that is what the method I have used here. So here I am having, you can see BD plus DE. So I am having BD plus DE, I am having BE, and CE plus DE, CE plus DE. DE plus CE is nothing but CD. So now I am having this whole one on LHS and this whole thing on my RHS. So I have written, I got the equation BE is equal to CD. So that's what we have to prove here. BE is equal to CD. So now I will write the third as BE is equal to CD. Now we have three parts to prove that the triangles are congruent. Now we are having B triangle BGE. This triangle is congruent to triangle DFC by SAS. Sorry, it is angle side. So it is angle side. What angles we are having is triangle ABD, angle ABD this angle, and angle FDE. So these angles we are having, and same way angle ACE this angle, and angle GEB this angle also we are having equal, and we are also having BE is equal to CD. BE is equal to CD. So we are having angle side angle. So triangle GBE, triangle GBE is congruent to, so this is the symbol of congruent, is congruent to triangle FDC. Triangle FDC. So just I have written rough. Now I should check whether the names are matching with each other. GFBD. So I should have GF and BD. So the lines or the angles that I have proved over here are matching with each other. So my congruent proving is correct. And at last I have said you we should write a reason also by angle side angle. We have to write it by angle side angle. So now they asked to prove in question BG is equal to DF. BG is equal to DF. So now, as these two triangles are congruent, I can write BG, that is this one, BG is equal to DF by CPCTC. So I am rubbing here and I am writing here only the question proving, only whatever it is there here I am writing over here, that is BG is equal to DF by CPCTC. Now I have another thing also to prove, that is CF is equal to EG. So this is CF, which is equal to EG, and this is also same by CPCTC. CF is equal to EG by CPCTC. So now we have proved the both. So let us go on to the next question. So the question is on your screen, that is, in the following figure, BL is equal to CM. So they have given one to mark us, that is BL is equal to CM. And also they have given some markings on the figure itself. So prove that AD is a median of triangle ABC. So this one, AD is median of triangle ABC. So let us think, we are having a triangle like this. Let us think, we have a triangle like this, and we have another triangle over here. Like this, and we have a line segments drawn in middle, that is we are having from here the one which they asked to prove. So now I am drawing a triangle, though it may not be the exact one, but I am drawing a rough one to just explain it to you. So a line segment is drawn like this. From here, this top to bottom like this, and we are having a joining line BL. We are having a joining line like this. Now let us name this triangle ABDC. This is A, B, D and C, and we are having L and M as well. L and M as well. And this both are given, it is 90 degree. So this sign represents it is 90 degree. If angle is drawn like this and it is like this sign represents 90 degree. So now they are asking to prove that AD is the median of triangle ABC. So we have to prove this AD is median of this triangle ABC, not this one. This triangle is not included. So, but in solving it is included, and they said median is only for the triangle ABC, not DCM. So let us think how to solve it. Now I will consider triangle BLD, and triangle DMC and triangle DMC. Now let us see what congruent parts are there in between them. So I forgot to mark one thing, that is this line BL is equal to CM, that is given in the question itself. BL is equal to CM. Yeah. Now I will prove the congruency now. Here we are having 90 degree angle BLD is equal to angle DMC. Angle BLD is equal to angle DMC. Now we can write in bracket, there each 90 degree. Each 90 degree. And next one, we are having BL is equal to CM. BL is equal to CM. It is given in the question itself. And what else left to remaining is, to prove congruent is, I can write this angle BDL, sorry, angle yes, BDL. So L is not here, it is here. Angle BDL is equal to angle MDC. Angle BDL is equal to angle MDC because they are vertically opposite angles. As I have said, when these two lines are drawn intersecting with each other, we can form a whole circle like this 360 degree, where this angle will be equal to this angle and this angle will be equal to this angle. Those are called vertically opposite angles. So angle BDL, angle BDL is equal to angle MDC. Angle MDC, vertically opposite angles. I am writing it with short form over here, vertically opposite angles. Now I have proved congruency, that is triangle BLD is congruent to triangle DMC. Triangle BLD is congruent to triangle, it is given DMC. DMC. So I will write triangle BLD is congruent to triangle, I am having CMD. Triangle BLD is congruent to triangle CMD. So thereby here we are having angle, side, angle. So it is angle, angle and side, angle, angle, side. So we should not pick up it randomly and we should see the order. That is, here we are having angle and here we are having angle, here we are having side. So they are in a sequence of angle, angle, side. We cannot write it as angle, side, angle. Like that we cannot write. By angle, angle, side. Now as it is of angle, angle, side, I will have DM is equal to DL. So DM will be equal to DL. So the same way, similarly, we are having BD is equal to CD by CPCTC. BD is equal to CD by CPCTC. So you know what is a median. when a triangle is drawn like this and a straight line, that is a line segment, is drawn from any vertex to here, these two parts should be equal, then only this line is called the median. That we all know. So now let us do the same way here. So as BD is equal to CD by CP CTC, so this line is joining or intersecting through them by its center point. At its center point it is intersecting, and BD is equal to CD, so it is center point. So when it is intersecting through its center, we'll call it as a median. So we should write like this: BD is equal to CD. That is very important, and we can write as AD bisects. So the term is used is bisects BC, line BC. So AD is median of triangle ABC. So AD bisects and line BC. So AD is the median of triangle ABC. So let us go on to the next question, as we have proved this question. So the question is on your screen. That is, here again a figure is given. The figure is also on your screen. We are having, use the information in the figure and prove AB is equal to FE. So first of all, whenever you see the diagram of the question, just make it a habit of writing whatever the information is given. So here I am having AB is parallel to DE and AC is equal to DE, and we are having angle EDF is equal to angle ACB. So that's all the information is available for us in the diagram. So now we have to prove AB is equal to FE. So we have to prove it. So consider triangle ABC and triangle DEF. Triangle ABC and triangle DEF. Now let us see what informations are available for us. AC is equal to DE. AC is equal to DE. That is one information available to us. And here you can see angle EDF is equal to angle ACB. Angle EDF is equal to angle ACB. And you can write in brackets for both them are given. They are given. And what else are given? So we don't have any another information available to us except AB is parallel to FE. So we have to pick up the equality or the congruent parts using these parallel lines. So you know, when a parallel lines are there, when two parallel lines are there, you have a transversal and you have a alternate angles. So like this, two parallel lines are drawn, one transversal, you have alternate angles. So here you are having interior alternate angles. So what is meant by this fancy term interior alternate angles? So if it is between the parallel lines, it is interior, and if it is somewhere like this and here, so it is called exterior alternate angles. Okay, now you know, hope you know what are alternate angles. So angle ABC will be equal to angle DFE. Angle DFE. Angle ABC is equal to angle DFE. Angle ABC is equal to angle DFE, and that's all. We have proved the congruency. Angle side we are having. So let us see what is that criterion. We are having here angle, so I am writing it here so that you will be able to understand this angle. So we are having angle side. Angle side. It is by criterion of AAS. And let us see what are the perfect namings. Triangle ABC is congruent to triangle EFD. Yes, triangle EFD. B we are having, so it should come in middle. So and last we are having angle C, angle D, so it should come last. Angle ABC is equal to angle EFD. Angle ABC is congruent to triangle EFD, and that is by AAS. So now we are having to prove AB is equal to FE. So AB will be equal to FE by CPCTC. AB will be equal to FE by CPCTC. So hence proved. So I am just rubbing the information that I have written in before, and I am writing here AB is equal to FE by CPCTC. So that one we have proved the first one. Now second one is remaining. It is given in the second one, that is BD is equal to CF. That means we have to prove this BD is equal to CF. But we know that BC is equal to DF. BC is equal to DF by CPCTC. When we place this triangle on this triangle corresponding with each other, we will have line BC is equal to DF. BC is equal to DF by CPCTC. Now what is BC actually? BC is nothing but BD plus DC. BD plus DC, which is equal to DF is nothing but DC plus CF. DF is nothing but DC plus CF. So as I have said in the previous question only, when we are having point A, point B, point C, we will have this line AC. So AC will be something length, and AC will be also equal to AB plus BC. So that is what we have done here. So the same way I have splitted it up. I can use the term split. So I have split this line into two names. So I'll get BD plus DC is equal to DC plus CF. BD plus DC is equal to DC plus CF. So when I transpose DC onto RHS, I will get DC minus DC. So I can cancel here itself. So I will get BD is equal to CF. So BD is equal to CF, hence proved. So that is the solution. So let us go on to the next question. The question is on your screen, the last question. That is, here a figure is given again, and ABCD and ABEF are parallelograms. So ABCD, so this one, and ABEF, so these two are parallelograms. It is given in the question itself. And here O is the midpoint of BC. Only it is of BC and not of AF. Show that DC is equal to CF is equal to FE. So that they asked to prove over here. So let us think how to solve it. Now just consider triangle ABO and triangle FCO. Now here triangle ABO, this triangle, and triangle FCO. You are having OB is equal to OC. OB is equal to OC. In bracket you can write it is given in the question itself. And what available informations to us are here. And we have also angle AOB is equal to angle COF. Angle AOB is equal to angle COF. Can you guess what is the reason? Yes, that's right. It is by vertically opposite angles. It is by vertically opposite angles. And what else we are having is, we are having angle OBA. Angle OBA is equal to angle OCF, because as it is given, this is a parallelogram. And hope you know the rules or the conditions what are there in a parallelogram. If a parallelogram is drawn like this, here you will have these two lines equal and this line equal, and they will be parallel. The opposite sides will be parallel also. So when they are parallel, and here we are having a parallel, and BC is a transversal for them. So these lines will be parallel and BC will be transversal. So we are having BC, if it is a transversal like this, that is it is cutting in between the parallel lines, we will have alternate angles. So when it is cutting like this, we will have angle OBA is equal to angle OCF. So these alternate angles we will have. So these two are the alternate angles over here. So we will have the last one as angle OBA is equal to angle OCF, because it is alternate angles. And now what we got from this? We got triangle ABO is congruent to triangle FCO. Triangle ABO is congruent to triangle FCO. And when we got that this triangle is congruent to this triangle, we will have AB is equal to CF. I can write it by CPCTC. AB is equal to CF. And when we have AB is equal to CF, and also we are having AB is equal to DC. I can write AB is equal to DC because the opposite sides of a parallelogram are always equal and parallel. So that is the main point you have to remember. So I will write AB is equal to DC. AB is also equal to DC. And what else we are having is AB is equal to FE. This AB is equal to FE, same pattern as this is a whole line without any cuttings and fittings in between. We will have AB is equal to FE as this line DC is equal, that is they are lying in the same plane, that is in DC, as DC is equal to AB, so FE also will be equal to AB because they lie in the same plane. And we can also say that these two, this is a parallelogram and AB is equal to FE and parallel to FE. So AB will be equal to FE as well. So the best reason you can write here is this one is a parallelogram ABEF. It is given here. ABEF is a parallelogram and AB will be equal to FE and AB will be also parallel to FE. So that parallel we are not using here. So now I have AB is equal to CF and also AB equal to DC. And this equation 3 I am having AB equal to FE. Now I am having AB is equal to CF which is equal to DC which is equal to EF. So as AB is equal to 3 of these, I can write so. AB is equal to CF, AB is equal to DC. So AB is equal to CF, I can also write as AB is equal to DC. So same way FE also. Now just on taking AB, actually we should write, also we cannot write for the proving questions, that is I can write if X is equal to Y is equal to Z, I can only take Y is equal to Z from this equation. I can only take X is equal to Y from this equation. I can also take X is equal to Z from this equation. So that's what I have done here. I will have CF is equal to DC is equal to EF. I will have CF is equal to DC which is equal to EF. So what they asked in the question is the same thing. Prove that DC is equal to CF is equal to EF. DC is equal to CF is equal to EF. So that's all we proved. At last you can write hence proved. So that's all for today's video friends. Thank you for watching my video. Do like, share comment and subscribe to my channel and click on the bell icon next to it. We are very near to 50 subscribers, so kindly support my channel and share the video to your friends and be helpful. So thank you for watching my video. Do like, share, comment and subscribe to my channel. Thank you for watching, friends. Thank you.